Hey everybody, today I will be going over the derivatives of the logarithmic and inverse trig functions. So to start off, I have a few of these definitions here for the derivatives of logarithmic and inverse trig functions. Now these are things that you really want to work on memorizing for your future checkpoints and worksheets and assignments and everything else like that. Because these aren't always intuitive. Like you can't really use the power rule, you can't use like a simple chain rule. They all require a lot of more complex math that's beyond the scope of this course. So for now, we just need to memorize it. First of all, we have the derivative of the natural logarithm of x, and that is going to be equal to 1 over x. Next, we have the derivative of inverse sine of x, which is equal to 1 over the square root of 1 minus x squared. This is very similar to our inverse cosine derivative. The only difference is we have this negative sign in front. So it's important to distinguish that. Finally, we have the derivative of inverse tangent, which is 1 over 1 plus x squared. So now we can hop into solving some of these problems. So right here, I see a natural logarithm. So that means I'm going to be thinking along the lines of this derivative right here. We don't have the natural logarithm of x. We have the natural logarithm of some function right here, x cubed minus 2x plus 8. So that makes me think we're going to need to use the chain rule. Before I start getting too ahead of myself, let's start working this out. So you have that f prime of x is going to be equal to 1 over everything inside there. X cubed, I don't really need those parentheses actually. That would be kind of pointless. 1 over x cubed minus 2x plus 8. That is that outer function, this red part right there. But now we need to consider the green part, the derivative of what's inside. So we're going to be multiplying by the derivative of what's inside. So then using the product rule here, sorry, not the product rule, I apologize, the power rule, you'll have 3x squared minus 2. And then that is our solution. You're welcome to rewrite this as 3x squared minus 2 over x cubed minus 2x plus 8. Those are the same thing. One is not necessarily better than the other. The main thing we ask, like when it comes to simplification, is really just like simplifying some basic fractions or exponents just to really show you understand the math. But in this case, like it means the same thing. So that is our answer for that part. Let's go on to number 2. I have g of x is the inverse tangent of e to the 3x. So once again, I have some outer function and some inner function. So I'm thinking chain rule again. So let's start out by taking the derivative of the outer function, which in this case, since we have inverse tangent, I will have 1 over 1 plus what's inside that inverse tangent, e to the 3x squared. Now I need to multiply by the derivative of e to the 3x, that green part. And that's going to be equal to 3 times e to the 3x. And that piece there is also chain rule. Okay, so I'll zoom in even a little more. I have that little function there. It's just to clarify where the different pieces are coming from. So just to make this a little bit clearer in the final answer form and simplify it, like what I meant earlier when I say like simplify your exponents, something like this right here. That can be put in a form that's a lot easier to understand. So anyways, in the numerator, I will have 3e to the 3x over 1 plus e to the 6x. And it's 6x because I have some exponent raised by another exponent, so we multiply those values together. And then this is our answer here. For part C, I see an inverse sign, a logarithm, and those are divided. So I might need to use a couple different rules here. So let's first think bigger picture. I'm seeing some big function divided by some function. So I'm thinking we're going to have a quotient rule. So let's just say that this numerator is equal to f of x. This denominator, I'll use a different color here, whoops, is equal to g of x. So first step for this question, taking the derivative, let's use that quotient rule. So in the sing-song way that I've talked about previously, we have low, so g of x, times the derivative of the high, f prime of x, minus the high function, f of x, times the derivative of the low function, over the low function squared. Now just to make this a little bit less messy as I go through and solve, how about we do our derivatives on the side over here? You totally don't have to. I'm just going to do it just for the sake of really going through and explaining these derivatives. So first, let's do f prime of x, where f of x is going to be equal to this numerator here. So first, I see an inverse sign. So I'm going to go up here and see that the derivative of inverse sign is 1 over the square root of 1 minus x squared. 1 over square root of 1 minus x squared. In this case, we're going to represent x is 2x plus 5, and that is squared. And this, using the chain rule, will be multiplied by the derivative of 2x plus 5, which is just 2. That part's good. Now let's consider the derivative of g of x. This is definitely a little bit simpler. We have g of x is equal to ln of x, and no frills attached, the derivative is just 1 over x. No need to really do a chain rule here, since that inside is just x. We could do a chain rule, but we'd end up just multiplying by 1, which is the same as 1 over x. All right, so with these values in hand, let's go ahead and plug those in to get our h prime of x. We have g of x, which is ln of x, times f prime of x, which is 2 over square root 1 minus 2x plus 5 squared, minus f of x, so inverse sign, times g prime of x, which is just 1 over x. So I'll just write it like that. And this is going to be all over gx squared. So ln of x squared. And this is our answer. Just from looking at it, I don't really see any good ways to simplify it. I think taking a common denominator in the numerator would really not get you anywhere. So for a question like this, where it's a quotient rule of just some complex functions, or sorry, complex might not be the right word, complicated functions, you can pretty much always just leave it as is unless you see anything glaringly obvious about how to simplify. So I'll leave it like that for now. overall, just the general structure of these problems, you have all the tools already. The only difference is we're just adding in these definitions that you need to memorize. But other than that, you know the quotient rule, you know the product rule, you know the power rule, you know the chain rule, you've had practice with that. The key is just not being overwhelmed by these complicated looking functions and instead just taking a step back and realizing that you already have the skills to do it. If you have any more questions about this, feel free to stop at office hours, but if not, good luck on the next checkpoint.